Hello, everyone. It is Friday, February 22nd. I am your host. This is sig-aws. I am your host and moderator, facilitator, Justin Santa Barbara. I work at Google. A reminder that this meeting is being recorded and will be put on the internet, and please be mindful of our code of conduct. We have a couple of things on the agenda. Excitingly, we have a demo of the AWS service operator from Chris Hine, which we'll get to in just a second. I just wanted to do a quick, I'll put the agenda in the link. In the chat, rather, if people do want to add things to that, please do so. I just wanted to add a quick public service announcement, which is we do have our AWS EDE testing, the Kubernetes AWS EDE testing back up again. So thank you to everyone that made that happen at AWS and anyone else that made that happen. Greatly appreciated. And so yes, we are back in business in terms of merging lots of PRs into everything. And I think we are going to make, as I understand it, we're going to make the tests we're not going to have them run on every PR, but we are going to have them run after every merge, is I think the current goal. And they will be made blocking, so that in theory the release will not happen with that. In theory, the release will not happen if AWS tests are failing. And with that, I think I will hand the floor over to Chris. Do you want to give us the demo of the service operator?
Yeah, absolutely. For those of you that don't know, the AWS Service Operator, its goals are to make it easier to actually manage AWS infrastructure using Kubernetes CRDs. As it currently stands, the project's in an alpha state. It was released in October of last year, and we've been pretty much just working on adding new features to it. I'll show you a quick run through of where it is today, and then I'll talk about where it's going to be pretty soon. Let's see if I can get my screen coming up.
Let's just do the GitHub link.
Yeah. Can you see my ID? Awesome. So currently what you can actually do with the AWS Service Operator is it manages multiple CRD types. So if we do kget CRDs, you can see in here the current version of it manages CloudFormation templates, DynamoDBs, ECR repository, Elasticache instances. The ENI configs is standard in an EKS cluster, and then we have the S3 buckets, SNS subscriptions, topics, and queues. And the goals here are really to get down to the lowest level of AWS constructs, so that it's very similar to the way that we build Kubernetes in itself. So you can reference other resources by their actual Kubernetes names instead of referencing things like ARN. So I'm really abstracting away the more underlying details of AWS infrastructure. And in this example, what I have is a sample application, and it's three different manifests, all in one single file, and it's really simple. So we basically have a DynamoDB, we have a service, and then we have a deployment. And the DynamoDB resource is the CRD that we're going to actually be deploying. And behind the scenes, what happens is when you deploy this, the operator's listening for those CRD types, and we automatically provision a CloudFormation template, which goes and creates the resource for you, which also gives us a nice way of actually handling updates of that stack as well. Long term, I want to integrate some of our drift functionality that we added into CloudFormation, so we can actually keep bidirectionally keep everything in sync. Now, the service is just standard load balancer. I've already provisioned that because it'll take a couple of seconds or a couple of minutes to actually come up and be alive. And then the last thing is just a very, very basic application, Golang application that is referencing a specific config map. And that config map, as you notice, isn't actually in this manifest. It's actually created by the operator so that we can have a very lightweight dependency tree between CRDs and the pods that would be technically referencing them. The similar analogy here would be something like application binding in service catalog. And so what we do is we're just using standard Kubernetes constructs to actually do that. So when this actually gets deployed, it goes into an errored state technically. So as the scheduler will be looking for the actual config map. And then after that, the actual resource gets provisioned in AWS. I get a notification using an SQS queue, and I will actually flip over, go and grab the outputs on the CloudFormation template, and write those to the config map, then allowing the pod to boot. So you never have an application in a state where it's constantly restarting while trying to connect to a data store. So if we actually go and do k-apply on this file, actually, before we do this, we can see we have no pods in here, and we have no get dynamo. We have no DynamoDB resources yet. So we do k-apply on the DynamoDB app. And while this processes, what we can actually do is I have a full update lifecycle that you can say get dynamo-o-yaml-w, and you can actually see the events as they come through. So this create in progress looks very similar to anybody that's worked with CloudFormation before. That's just the status coming directly from CloudFormation, as well as the stack ID and the status that's actually being reported. So we can basically just sit here and watch this process, but I'm going to flip over and show the pod as well. Okay, get pod. And you'll see that that's in a create container config error state. So going back to here, I'll wait. So it looks like that actually just flipped over to create complete. So now I can actually say, go look for the config maps. Okay, get CM. And now you'll see that there's a config map in there. And if we go and get the pods again, we should see that the pod came up and it's in a running state. And the load balancer that I provisioned beforehand, it wasn't routing, will eventually, after it finally goes through its full cycle, there. And it's really basic. So like this application is just a really simple implementation of it. There's ways that we can use this, and I have another demo that actually goes into deploying an S3 bucket as a static website. So you never have to actually do a static file store. You go and actually deploy a static S3 bucket as a website. You use a Kubernetes job to then hydrate that with like HTML pages. And you can configure those to connect directly into like these load balancers that you're connecting together. And it creates this environment where you can strip away the multiple pipelines necessary to actually deploy your applications using AWS services. And that's pretty much my demo.
That is an awesome demo. Just FYI, we couldn't see the website at the end, but I presume it said hello world or something. But that is, right. We were just looking at the IDE. But that is really cool. I don't know if anyone else has any questions. I have one question. Oh, there we are.
Sorry about that.
There we go. Very cool. I have one question, which is config maps, and should we try to make it? I guess it was quite. So I liked the way that the config map meant that the pod net didn't start until the config map was ready. But it is a bit of a pain to have to like refer to some other object, and I'm wondering if we should make it possible to refer to like your CRD itself, the instance of the CRD itself.
Yeah, I've been trying to figure out a good way of doing that.
I think we have to be Kubernetes, right? It would have to be a Kubernetes change. Yeah,
I would love to explore that more if you're interested in talking about that.
Yeah, it's definitely worth thinking about. I think it might be a API machinery question. It's more like, is this going to be a common use case that like happens a lot, and should we think about it? But I think we would lose the great thing you have there, where the pod is in that state I'd never seen before, container something create.
Config error.
Yeah, that was great. They surfaced the error nicely. That was awesome.
It's an interesting state because we also have it so that it can do that with secrets as well. So pretty much any of those kind of referenceable resources. What I didn't also talk about was where it's going. This is also a big thing for right now. I'm heavy in development of this. I'm just going to share my screen again because I have something to show here. What I've been doing is we have can you see Cloud9 again? Cool.
We can, yes.
Awesome. Okay, so what I've been working on currently is actually going back and code generating all of our CloudFormation resources. So we have a public CloudFormation spec that loops through every single resource, and it pretty much describes how the CloudFormation templates look like. And so what I've done is I've gone through and I actually have all of the CRDs generated for it, which gets really crazy. So this is going to be a really interesting case long-term to figure out how CRDs actually scale, because it's about 345 different resources all being exposed. And so the new version of this is getting a lot of new features. So I was mentioning that we have new ways of actually referencing objects. What I've done is I've modeled it after the way that we do config maps. So for example, in this resource, this is a API gateway account specifically. And in the API gateway accounts, you have a CloudWatch role that you usually would reference by an ARN. But what I've done is I've made it so that you can pass in manually an ARN representing the physical resource that you've created outside of this. Or what we have is we have CloudWatch role references. And those represent, similar to what we do with config maps, where you'll pass in a name and a namespace, and it's going to be able to find the actual resource based on the outputs of those stacks. And you'll see in here, just in this CRDs list, you'll see we have like all of the different kind of group names. And then under each one of them, there's anywhere from 1 to 20 different resources for each individual type. So I've been really interested in seeing where this is going to go from a scalability perspective on the actual API server.
Have you tried loading them, and what happened?
Loading them is fine. I haven't tried putting any pressure on it, and I don't have the actual, like, the operator code is what I'm working on pretty much today through next week. Yeah. So for right now, when you load them in, it's nothing, no big issues. You can go and create resources against it. It's not a problem. It's not that slow. Listing them is quite slow though. So if you do like get CRDs, it takes probably about 15 seconds to load all of them. So,
that's surprising.
So I want to dive more into that and see what's going on.
Yeah, I'm sure this is one of those things where like the core will improve when people use it in anger, right? And I'm sure there were some optimization or time optimizations taken that were not CPU optimizations.
Yeah, I'm absolutely sure it's something like that. And I think this is a good test because with all the conversations that we had at like KubeCon NA about moving core functionality out of tree, I think this is a good use case where it's like, let's put a lot of pressure on the amount of CRDs we can handle. So.
And I guess using CloudFormation instead of going directly basically makes it so that you don't have to rewrite CloudFormation and that you can auto-generate all that stuff, right?
Exactly. Yeah, I'm treating CloudFormation as like a pseudo scheduler, and then every single the actual update lifecycle happens because every single resource has an SNS topic, and then I have SQS subscribing to those, and every single event goes through that queue system. And so in Kubernetes, if you do kubectl get or kubectl get events on a specific resource, you can actually see all of the individual stack events as well. So you never have to go through and load up the AWS console.
Very cool. I don't know if anyone else has any questions or thoughts.
Dan, yes, those are public already. There's one in the chat. So the project did the project get put in there?
I did not. I don't think I got it in yet. I was distracted, sorry.
No worries, I'll put a link in there. The project is on GitHub, fully available currently. The new CRDs are not public yet. Those should go out pretty soon though.
Awesome. Well, looking forward to that. That's really great.
Cool, thank you.
Thanks, Chris. And I think we have a proposed demo from Alex Tanton in our backlog, which I'm guessing he wants to demo the, or he or she, I guess, wants to demo the AWS EKS cluster controller. Looks like it's open source from AWS Labs on GitHub. So I guess we will schedule that for 2 weeks, unless anyone has anything else they propose instead. But I think
check with him. He's going on vacation, I think, that week. So let me confirm with him that he'll be able to make it.
Maybe later, but yes, please do add things that you would like to demo, like that wonderful demo. I'm not sure what will live up to that, but that was a great way to get us started. Thanks, Chris, and add demos to the backlog. Anything relating to AWS is great. Thank you so much. And all right, we have 3 more items on the agenda. We have node name as the internal ID instead of the internal IP. And then we have, Nishi, do you want to go next? Because your topics seem like they might be a little faster. Makes sense. Although your mic, are you saying anything, Nishi?
Oh, I was having a problem with my mic. Yeah, I'm submitting 2 GSOC projects. I wanted to see if anybody has any ideas, as we discussed last time, for sig-aws, any missing feature that you want to propose. But I have two ideas on the testing side of things and for existing sub-projects. And also the IAM authenticator, some pieces are missing there, so I will be submitting the GSOC apps today. The last date is today. I just wanted to see if anyone else has any ideas.
That sounds great. Thank you. For those that don't know, GSOC is, do you want to tell us what GSOC is, Nishi?
Google Summer of Code. So it's an internship opportunity for other people. You'd get the opportunity to mentor these interns as well. But if you guys have any ideas, by end of day, just send me the thought of what you could do or what could be an idea that we could offer. The other thing was I gave a community update yesterday on all of the projects. That'll go out in 1.14. So if you need the slides or the update, you can check the SIG community meeting tomorrow that happened yesterday. All right.
Thank you, Nishi. Guess I totally spaced and forgot that meeting, so thank you.
It's fine.
All right, and then thank you, Nishi. And then the other item that I skipped over because I sensed it might be a little longer is a discussion about Mike. Do you want to kick us off on this one?
Yeah, looking at your looking at the issue that you listed, it might be a different issue. The one that was raised, I think 2 weeks ago now, was the cloud provider has some strong assumptions about the nodes that it finds use the private DNS name in the AWS in the AWS API as assigned by the VPC's internal DHCP server, which totally breaks people's workflow when they're running like private custom DHCP option sets where they're assigning different DNS servers and then are getting different host names than what the VPC gave them, or are manually overriding the host names. Does that sound kind of what you were talking about, Justin?
I think it's all related, yes.
Okay.
I think there is supposed to be code in there that's supposed to look at the DHCP options and deal with it, but I don't know whether it's certainly overriding the node name directly will cause this to fail. Sorry, go on.
Sorry, go ahead.
I was just going to say the original reason why this was there is because the node name had to be routable anyway, in the long time ago now, and so that was sort of the reason, and we never fully been able to break it. The reason why I think it's the way I propose that we do this is we currently pass around the node name a lot. And if we across the cloud provider interface, and if we instead passed around the node, then we could go and look up the instance ID or any other data that we wanted to in there. Then you could in theory, I guess you could name all your nodes. Well, you don't name all the same, but in theory, you could name your nodes all the same if Kubernetes let you, and we would still be able to deal with it. So that's why
the more correct approach, though, as you alluded to, is to just use the instance ID. Because that's not customer changeable, and it's gonna persist the entire lifetime of a node.
Yeah, I guess there's two steps, right? There's the let users run the instance ID instead, which actually might be easier, and then there's we don't care about the node name at all. We can actually just go and look at the figure it out from the node object, which has the instance ID baked into it. Right. In theory, we could start to put other information on there. So right now it's pretty inefficient because when the AWS cloud provider gets a node name, it has to go and do a describe instances call unless it knows because typically it uses an instance ID. And so unless it knows what that private DNS name maps to, it has to do a lookup.
Right.
But yeah, so I did one PR where I changed one of the methods that I knew to be tricky, just for sort of discussion of this issue, where if we wanted to pass a node object around, the biggest barrier is the persistent volume controller, which runs on the master and talks in terms of nodes. And you can see that it's bad, but it's not that bad. It's not as bad as I remember it being. So we could make the node if people we could pass around the node. If people actually just want to do the instance ID, that is a lot easier.
Yeah, I think from a making it more bulletproof on our side, on the side of the cloud provider, I mean, the instance ID is the best thing for us to use, but passing the node object is probably the right code interface to do it. I just poked at the code a little bit more, and it does use node registration. The node controller side of that also needs that private DNS name, so I'll kind of have to clean up that. But I think my opinion is that your approach is correct, and I'm in for that.
I think it'd be good to pass the node objects around. I think we'll likely hit some issues, and I think it might be tactical to implement support for like this starts with I- and like does not have a dot in it, and so therefore it's an instance ID type thing.
Yeah.
I think that would work. I don't know if other people have any requirements or requests around the format of node names that are like any guidance on whether we should do anything other than the instance ID or private DNS name, I guess.
Dan B, who's in the chat, and he and I had talked about this a bit on Slack, says +1 for instance ID.
So for Google GCE, the host name of the node is used, right?
Correct. So Google GCE has a tighter association. They instances in GCE are named, as in you give them a string name, and that string name is used as the node name, and that node name is resolvable like via DNS inside the cluster. And I don't think it would be supported to use an arbitrary node name on GCE either, but it's sort of less of a concern, I guess, because the node name or the name of an instance is a primary concept on GCP, whereas on AWS it is more flexible, I guess you'd say, and it's just a tag, right? You have the instance ID, and then you have tags for whatever you want.
And that node name, is it determined using kubelet, or is there some other way for the node name to be determined, like the host name?
So the host name is the node name, and the kubelet registers with the host name.
But you can override it as an option in the kubelet.
Oh.
You could pass an override. I think it would break things on GCP.
Oh, okay. Yeah, at least in the AWS case, it does fix this issue if you pass the override.
I do think you can override it using host name override also in GCE. But then I don't know how you would, if you do the host name override, I've never tested what is the other option of actually recognizing that name.
Yeah, my guess is it would be the same thing as on AWS, where in particular, like PVCs would break because they refer to the node name. They pass that in and they say mount this volume on this node name, and the GCE cloud provider would go and try to resolve that node name with an instance lookup, and it would be like, I don't know what this node name is.
Got it.
That'd be my guess.
Sorry, I didn't catch the initial context of Mike's question, but Mike, the private DNS way of doing things was always there with the cloud provider entry code as well. So
correct.
Where do you see there being a problem? If you don't mind reading it again.
The problem as exists today is if you're using anything except the default VPC configuration, then you break those private DNS names. The kubelet detects the host name that you've overridden. It cannot do the describe instance call to AWS because it tries to use that as the private DNS name that AWS wants. The one on AWS disagrees with the one that you've overridden, so it does break everything. That's the same for in-tree and out-of-tree. If we break that assumption, if we say that the host name is customer controlled and therefore not to be trusted for the purposes of looking up these instances, and use something like instance ID or something more stable that the customer doesn't control, then we can kind of fix all of this. The short-term solution, if you run into this problem that I did end up testing, is if you start the kubelet with the node name overridden. I forget the exact name of the flag, but it might be like node override. And also the node IP overridden to the primary IP of the instance, everything just works. It's an ugly hack, and you have to do it on the cloud controller manager, you have to do it on the API server, and you have to do it on kubelet for every single kubelet in your fleet, but it does work.
I see. And the issue that you're talking about is in the Google Docs. Have you raised an issue here? Is there an issue that I could look at?
There are 4 or 5. I didn't count them. They're linked in the meeting notes.
This has
and
been
then
like one of
Justin's
the
got his
long
PR
running.
as well.
Okay.
Yeah, like this and low balancer naming are the two that like I sort of have the canned answers for. I should just write a doc being like, here's why load balancer and renaming is hard, and here's why instance node renaming is hard.
And I missed the cutoff for 1.14 to fix this, but this is very high on our priority list, at least here at AWS. If somebody else wants to pick it up, more power to you. But we will shoot for have this in 1.15 as fixed.
One of the things that I'm not sure how this interacts with is there is a move to not trust the kubelet, or not trust the kubelet, but minimize the security trust in the kubelet, and so not allow the kubelet to specify taints, for example. And I don't know whether we would allow the kubelet to specify its instance ID or its name or anything in future. I'm going to guess we would, but I don't know. So that's TBD, I guess.
Now, do you know if this is something that kubeatom is doing today as of 1.13, it restricting that trust boundary?
I don't think so. My understanding is it's not implemented.
Okay. All of my testing was with kubeatom on 1.13, so for whatever that's worth.
And I think we have, I don't know, I can't remember the code that gets around DHCP options is in Cloud Provider or is in COPS, but I can have a look at, and try to figure it out.
I don't see it in Cloud Provider. I was just digging through that.
Okay. I thought the instance, when it came up, looked up its own ID, looked itself up by ID, and then got its own private DNS name and used that to override the host name. But I don't know.
What I saw is it's looking to try and translate the DHCP name into a node name, but all it does is it just strings that and returns the value you pass into the map function. So maybe, I don't know, that's as far as I got just poking at it.
I'll have a look, and if I find anything, I will. Well, I'll try to remember what I was thinking about, and then I'll send it to you on Slack or something, or I'll put it in send it to you in Slack and put it in the notes. How about that?
Perfect. And then what is the just procedural question? We've got 4 different issues that all reference this one kind of user-facing issue. Do we want to try and like dedupe those and fold them down into one issue that we track, or just leave them all open?
I think it would be great to create an umbrella issue. It is work to do that, but I think that would be reasonable to do. I think if there's particular context in any issue that is important not to lose, which I don't think will be the case here. That is the case for like some of those weird like bugs where something doesn't behave right. But in this sort of case, I think we pretty much understand it, and we can close and create an umbrella issue, close it, link them, and be like, if you have any context you think is important, please do copy it over. And
okay,
that sort of thing.
I'll take that on then.
Oh, sweet. Thank you, Mike. All right, we have another item on our agenda. Cheng, this sounds scary, undocumented EBS volume ID format.
Yeah, so I'm not sure if undocumented is the best way, but at least this is some problematic ID I noticed during the CSI migration, because I brought up in the SIG storage, but seems because of this whole driver thing is going to become out of tree and actually gets less attention from the SIG storage. And also got some comments from Yang and Hamant on the issue. So I want to bring up on SIG AWS to see if you guys have any opinions on this. Basically, it's like for the volume, persistent volume, there are 2 ways we can specify the volume ID. One is using the traditional like EBS volume ID as it is. Another way is like prefix with AWS comma / things like that, which is problematic in the sense that it's going to be interpreted as a pass on the file system, so that actually their actual directory is going to be created. Like there's going to be AWS directory, which is going to be created under the kubelet plugin, like a parent directory or somewhere, which sounds scary. And I wanted to know what's the history about this, why this is being created this way. At least I haven't seen this happening on other drivers. And also, is there any people using it, or like, how do you guys think we should close the door, or like, because from the migration perspective, I talked to David, seems that's not, at least from his point of view, that's not a concern for the migration. So I think that's something we need to make a decision on the SIG AWS side.
As I recall, there was a reason why we cared about the zone, I think, back in the day. And so that's why this syntax is designed to be able to get the zone in there. I don't remember the details. I will have a look at the issue. Yeah, CSI migration is definitely going to be challenged. Like it's a big topic, and yeah, I can't imagine anyone is using it, but we have to maintain compatibility, I think. But I will read the issue. I don't know if anyone else has any context on this or relies on it anywhere.
Yeah, that's the tricky part actually. Like at least given my testing, without the zone, just the idea itself works. But just because of the dynamic provisioning, actually taking this zone one as a default format. So if whoever uses dynamic provisioning gonna be getting into this issue. And speaking of the actually Kubernetes upgrade, I'm wondering how are people usually doing this kubelet upgrade? Is it like they can keep those volumes around by just killing the kubelet and then spinning up a new version, which sounds hacky, or just if they can drain the nodes along with volume, so this problem is workaroundable in my opinion, right? Because of those passes actually deleted and the node is gone and the volume is detached. Once the new kubelet is up and running, it should do the new thing like without this pass, like the AWS in the middle.
Yeah, I think the good news is because this is the AWS driver, like if it was bare metal, people are going to upgrade in place. I think on AWS, as far as I know, all the tooling brings up a new instance for a kubelet upgrade at least. Like kops will bring it up if you change, will like replace the instance if you change a flag, which is probably going too far in that direction. But you know, I believe that most tooling works that way. So you could certainly make a CSI. You could make it part of the CSI upgrade procedure that you don't replace the instance, don't upgrade the instance in place if that turns to be an issue for AWS, that you don't upgrade the instance in place, which I don't think anyone will mind. Like I don't know. Does EKS doesn't take an opinion here? Is that right?
I think we don't manage worker nodes now. Like basically, customers need to handle it. They can choose whatever approach they want.
Is there a suggested workflow that points them towards a in place versus not in place upgrade?
I'm not sure. I'm just looking for like a community best practice to begin with, and to gauge how serious this problem is.
Yeah, in terms of what the Kubernetes open source community has done, most of I think all of our E testing does upgrades by replacing the nodes entirely. We don't do any, as far as I know, we don't do any in-place upgrades of kubelet. And I don't think we do any in-place upgrades of even like the control plane.
Mm-hmm.
Maybe the kubeadm upgrade tests have that. I don't know. I don't know if
from the EKS side of things, we have both flows supported. We have documentation for doing both, and then with EKS Cuddle, we're working on doing rolling new instances for everything, for every upgrade.
If you're on the cloud, it does seem like a nice way to do things, but yeah, I don't know. I don't know the details there.
Yeah, sounds like given both approaches could be existing, like basically for this problem, we have to carry along with this format for a certain period of time and then see. Sounds like right?
Probably, yes.
Okay. All right. Cool. I think that's all what I want. Like,
Awesome.
Good enough for me.
I don't know if we have anything else on the agenda. Looks like we've hit the end of our agenda, or we've covered everything on our agenda. If anyone else wants to bring anything up, please do so. Otherwise, we will call the meeting. Going once, going twice. All right. Thank you, everyone. I wish you all a very happy weekend.
Thanks. Happy Friday.
Happy Friday.
Thank you.
Thanks.